How you doing, Year 10s, and welcome to another episode. We're still in our What Are the Types of Chemical Reactions series, and this time we look at electrolytic cells. Let's jump to it. Okay, so what are the types of chemical reactions? Electrolytic cells. The understanding and outcomes are you need to have an understanding and be able to outline what type of metals are formed from electrolysis, and you need to be able to label an electrolytic cell. So electrolysis is the process of passing electricity through a molten salt, a molten ionic compound, to extract a reactive metal. Electrolysis can be used to extract any metal from its ore, that is from what we gather from the ground. However, it requires large amounts of energy. Typical metals that are made through electrolysis are aluminium, sodium, iron, copper, and nickel. In fact, I watched a video where the aluminium plant down in Portland, it used to cost them $500,000 each day in electricity to make the aluminium. So a large amount of electricity is required. So we can produce sodium metal and chlorine gas from a molten sodium chloride solution. I don't want to call it a solution, but it's not a solution, it's a liquid. So it must be molten. It's a molten sodium chloride. Now that's because we can't have any H2O in the system, because H2O will interfere with the reaction. Now what happens here? To break apart the sodium chloride crystal, we would have to heat it to really large temperatures. So we break that apart and that releases sodium ions in a liquid and chloride ions in a liquid. If we have two electrodes and we put those electrodes into the solution, then we can pass electricity through it. The ions are free to move. So in the diagram here, this short little fat one, that's the negatively charged terminal of the battery. The long skinny one, that's the positively charged terminal of the battery. Those little dark rectangles, well, they're the electrodes. That's what we would place into this liquid. In our liquid, we have chloride ions and sodium ions, both liquids because there's no water around. Now the battery pumps electrons into the negatively charged electrode and pulls them out the positively charged electrode. So that means that our electrode on the right is negatively charged. Well, if it's negatively charged, the sodium being positively charged will be attracted to that electrode. The chloride, it's negatively charged, so it will be attracted to the positively charged electrode. We call this a migration of ions, and this migration allows the current to flow in the solution. Electrons can't swim, so the electrons don't move through the solution. It's just the ions that move either to the positive or negatively charged terminal. Now when they get to that electrode, a reaction occurs. The sodium ions will gain an electron from the negatively charged electrode to form sodium solid. The chloride ions, as they make their way towards the positively charged electrode, they will lose an electron to form chlorine gas. So sodium goes from an ion to a solid, or a liquid, because we've got this at a high temperature, so the liquid would float to the top. And our chloride ions, well, they turn in from an ion into chlorine gas. So we just need to balance that correctly. 2Cl minus goes to Cl2 gas plus 2 electrons. So this is the production of sodium metal, a very reactive metal, from electrolysis of a molten salt. The ions migrate towards the oppositely charged electrodes, and then the reaction occurs there. Another important application of electrolysis is electroplating. And electroplating involves a metal object being plated with a less reactive metal to avoid corrosion or tarnishing. The object that we want to coat must be connected to the negative terminal of the power supply, and we must have ions of the metal we want to coat in the solution. So for example, if we wanted to coat a house key with a copper metal, then the key must be connected to the negatively charged terminal, and we must have copper metal ions in the solution. So We can draw a diagram of this by setting up our beaker. In our beaker we would have our solution of copper 2+ ions, maybe something like copper sulfate, which is that nice blue solution that we've talked about before. We set up our electrolytic cell, so we have our battery. Our negative terminal must be connected to our key, and the positive terminal is just connected to another electrode. Generally in an electrolytic cell, that electrode would be made of the same metal that you want to coat. So if I wanted to coat copper, then my other electrode would be made of copper. If I wanted to coat silver, the other electrode would be made of silver. This is the exact process that they use for silverware. So if your parents have some nice silver-coated silverware, this is what they would have done. They would have connected the knife or the fork up to an electrolytic cell, silver ions in the solution, and then that would have plated the silver onto the cutlery. So here I've got it set up. I've got my battery up there. The short little fat one's the negative, the long skinny is the positive. I've got my key connected to the negative, and that means that the electrons are going to be pushed into the key. The copper ions in the solution will then form a copper coating on the key, and at the other electrode I will have my copper solid, because I want to try and replace any of those ions that have gone from an ion to a solid to keep it balanced. We can't plate all different types of metal. There's only a few specific ones that we use for electroplating. So when we start to run this cell, we'll see that the key will be coated with a thin layer of the copper. The longer that we leave the key in the solution and the longer we leave the battery on, the more coating the key will get. Thanks for watching, guys. Don't forget, drop a like on the video, subscribe if you're new, and I'll see you next time.